This interesting area within Endeavour crater's rim is where many clay minerals have been detected from orbit. In the image, you can also see two of the features that were investigated by Mars rover. Copper Cliff, the dark outcrop in the left center of the image, and Whitewater Lake, the bright outcrop on the far right. This image snapped by the Mars Reconnaissance Orbiter shows some strange formations on the surface of the red planet. The dark raised areas are a series of dunes that look a lot like the dots and dashes of Morse code. These dunes are influenced by local topography. The shape and orientation of dunes can usually tell us about wind direction, but in this image, the dune forms are very complex, so it's difficult to know the wind direction. However, a circular depression, probably an old and infilled impact crater, has limited the amount of sand available for dune formation and influenced local winds. As a result, the dunes here form distinct dots and dashes. The dashes are linear dunes formed by bidirectional winds, which are not traveling parallel to the dune. Instead, the combined effect of winds from two directions at right angles to the dunes funnels material into a linear shape. The smaller dots called Barconoid dunes occur where there is some interruption to the process forming those linear dunes. The evenly layered rock outcrops seen here shows a pattern typical of a lake floor sedimentary deposit not far from where flowing water entered a lake. The thick, laminated stratified rock type forms stratigraphically beneath cross-bedded sandstones. They are interpreted to record sedimentation in a lake as part of or in front of a delta where plumes of river sediment settled out of the water column and onto the lake floor. This image shows the Payson outcrop on the western edge of Aramis Crater. From this point at the northern end of the outcrop, layered rocks are observed in the crater wall, which is about 1 meter thick. The view also shows rocks disrupted by the crater forming impact event and subjected to erosion over time. To the left of the outcrop, a flat, thin layer of spherule-rich soils overlies more outcrop materials. Perseverance Mars rover viewed these interesting rocks using its Mastcam Z imager. For scale, the largest piece of rock casting a shadow in the upper right part of the image is about 11 inches across and the entire scene is about 10 feet across. The smallest pebbles and other features are around 1 to 2 millimeters across. This is Endurance Crater, where data collected by Mars rovers have shown that there had been liquid water here in ancient times. Endurance provided scientists with a cross-section of the bedrock on this part of Mars, showing that liquid water hadn't flowed across the surface just once but was of an episodic nature and wasn't permanently present, with floods periodically washing over the landscape and then drying up again. Interpretation of the materials such as sulfates in the crater's evaporite outcrops led scientists to believe that this shallow sea was probably rather acidic in nature, but couldn't rule out that life may have been present at some point. This view from the navigation cameras on Perseverance rover shows the Martian landscape during the rover's drive using its auto navigation function. The auto navigation algorithms allow the rover to drive quicker and more efficiently than its predecessors. The software also identifies rocks as hazardous and deviates the rover's course around them. Curiosity rover took this image of the Kimberly formation on Mars. The strata seen in the foreground dip towards the base of Mount Sharp, indicating flow of water toward a basin that existed before the larger bulk of the mountain formed. This dark, smooth-surfaced object at the center of this image was examined with laser pulses and confirmed to be an iron-nickel meteorite. The grid of shiny points visible on the object resulted from that laser zapping by Curiosity's chemistry and camera instrument. The meteorite is about the size of a golf ball, and it was the first meteorite on Mars to be examined with a laser firing spectrometer. This image shows several holes that the Mars rover's rock abrasion tool dug on the inner slope of Endurance crater. The rover was about 12 meters down into the crater when it took this image. The tailings around the holes show evidence for fine-grained red hematite, and each hole is 1.8 inches in diameter. Cloudy days are rare in the thin, dry atmosphere of Mars and are typically found at the planet's equator in the coldest time of the year. Nevertheless, Perseverance rover captured these clouds drifting over Mount Sharp. Perseverance rover spotted this hollowed-out rock in the Zero crater using its Mastcam Z instrument. Wind can erode all sorts of strange shapes like this by sandblasting rock surfaces over the course of eons. In this panorama, to the right of the center and near the top of the frame, the rim of Endeavour crater rises in the distance. Just to the left of that, rover tracks can be seen which were left during their descent from over the horizon towards Perseverance Valley where this panorama was taken. Perseverance Valley is a system of shallow troughs descending eastward about the length of 2 football fields from the crest of Endeavour's rim to its floor. A hill with a V-shaped collapse structure, 2 craters and a circular fracture pattern, possibly the remains of a buried impact crater, appears to have formed the face of a bear on this Martian surface. This view looks west toward the rim of Mars's Z0 crater. The rover's Mastcam Z instrument captured the image when Perseverance was about halfway through a boulder field that was 1 kilometer wide.